Alright, so this is part 3 of 12.2 videos. Hopefully you've done the first 2 parts already, and hopefully you've worked out this problem already. So now I'm going to work it out, and you can check your work and see if you know what's going on. Alright, well, I'm starting off with 6.54 grams of potassium chlorate. They give us the formula, so we don't have to figure it out. But I don't want my grams, so that's easy enough. Now the only thing I can change grams to again is the mole. And it's always 1 mole. Now to get my grams of KClO3, I'm going to go to my periodic table. Now I have 1 potassium, 1 K, I have 1 Cl, and I have 3 oxygens. I go to my periodic table. K, potassium, is 39.1 grams. Chlorine, Cl, is 35.5 grams. And oxygen is 16 grams. Alright, I need to add all of those up. Let's see if I can do this without a calculator. $122.6. That number gets up there. It's always for 1 mole. I'm going to cross off my like units. And while I'm at it, I'm going to put my chemical up here. So now I'm in moles of potassium chlorate. I don't want potassium chloride. I want oxygen. Alright, so my next step, I want to get out of my KClO3. So I'm going to take my units here, transfer it down there. Alright, what do I want? I want oxygen. Well, oxygen is O2 because it's diatomic. Alright, so I'm going from that to that. To get my mole ratio, my numbers, tells me there's 3 oxygens, 3 O2s for every 2 KClO3s. Make sure you match the formula here. A lot of times people will take this one, happens to be the same number, but make sure you match them up. Alright, I'm going to cross off the things that are matching. I don't need those anymore. I'm in moles of O2, but I want molecules of O2, so I need to keep going. I'm going to take my units here, put them down there. And I'm looking for things, I'm looking for molecules. Whoa, don't want that. Alright, and for things, I just use Avogadro's number. And it's always 1 mole. It's always 1 mole. Alright, I'm going to cross off things that are similar, top and bottom, and I've got everything I need. Okay, now to summarize, I'm going to take my 6.54 and times it by 3, that's on top, times it by everything else that's on top. And then on the bottom, I got my 122.6 and my 2. And I'm going to take my scientific notation and leave that till the end. Alright, so I'm going to plug all of that into my calculator. Let's see, what do I get? I get that. So all this in my calculator is 0.482 times 10 to the 23rd. You can leave it like that, but your book's not going to. They're going to put it in proper scientific notation. So I'm going to move that decimal over 1 space there. Okay, that number just got larger by a factor of 10, so to compensate, this one has to get smaller by a factor of 10. So from 23 to 22. So that's my proper answer. Okay, again, you're fine leaving it like this, but on a multiple choice test and in the back of your book, you're going to see this format. Alright, go ahead and try this one. Pause the video, work it out, and then come back and check it. Alright, so let's see. I'm starting with molecules this time. So a little bit different, but the process is the same. Molecules of nitrogen monoxide. How do you know what nitrogen monoxide is? Well, mono means one oxygen. So that's this guy. Trying to get the eraser to work, and it does not work, so I'll go over here. Alright, so I have that many molecules of nitrogen monoxide. I don't want my nitrogen monoxide, so even before I know where I'm going, I'm just going to put it down here so I can cancel it. Okay, well, we're going to grams of nitrogen dioxide, so a different chemical, and I'm going to grams. So I got to get out of NO and N to NO2. Di means two, so two oxygens. Alright, so I'm going to go, actually first, I cannot go directly from molecules to molecules. I can't go from things to things. I can only go things to moles. So from molecules, the only thing I can go to is moles. And if I'm in molecules of NO, I need to go to moles of NO. Okay, again, molecules. I'm not going to have room for that, but it's 6.02 times 10 to the 23rd things. It's always 1 mole. Alright, I'm going to cross off my like units. Alright, so now I'm in moles of NO, but I want NO2. So I'm going to get rid of that. So I'm in moles of NO. I'm going to put it down there to cancel it. I want to get into NO2. So to get out of one chemical into another, I make a mole-to-mole ratio. What I'm going from, what I'm going to. How many NO2s? There's 3. How many NOs? 1. Cross off my like units. Now I'm in moles of NO2. I have the right chemical, but now I'm looking for grams, so I need to do another one. Don't want that stuff. And I do want grams. How many grams in a mole? Well, grams to moles, it's always 1 mole. And I go to my periodic table for the grams. And I have nitrogen, I have 1. And oxygen, I have 2. I go to the periodic table, I look up nitrogen. And I go to the periodic table, I look up oxygen. So 1 nitrogen at 14, 2 oxygens at 16, and I add them together. And that's my molar mass. I cross that off as I go, and I'm all done. Now let's go ahead and work this out here. I'm going to go up here. Let's see, I have 5 times 3 times 46. That's 5, 3, 46. On the bottom, well, I just have 6.02. Now my exponents, I have 10 to the 22nd up here and 10 to the 23rd down here. Well, I need to subtract those. 22 minus 23. Alright, now to clean that up, I'm going to put all of this stuff in my calculator. This will actually do it. 5 times 3 times 4.6. Whoops. 5 times 3 times 46 divided by 6.02. Now I got it. Alright, and again, that's an acceptable answer, but to put it in proper scientific notation, we're going to move the decimal over 2 spaces. So move it over 1, 2 spaces. And since I just made that smaller by 2 factors, I need to make that bigger by 2 factors. So 10 to the positive first. So there's my answer. Alright, now we're going to go liters. Liters tend to be the easiest. But I'm going to start off with 34 liters of oxygen. I don't want liters. So I'm going to put it down here. I want liters of nitrogen dioxide, so I need to get into a different chemical. So first thing I got to do is get out of liters, because the only thing I can change liters to is 1 mole. And it's got to be the same chemical. So 22.4 liters of O2 per 1 mole of O2. Cross off my like units. Now I'm in moles of O2, but I want a different chemical, nitrogen dioxide. Again, di is 2, so we're looking at this guy right here. Don't want moles of O2, so I put it down there. And I do want my other chemical, so this is a mole-to-mole ratio. In O2, there's 2 NO2s for every 1 O2. Cross off my like units. Looking for how many liters, so I got to keep going. Don't want moles of NO2. And I want liters. And my liters, 22.4 liters for every 1 mole. Cross off my like units and multiply that out, divide it out, and we get 68 liters. Alright, go ahead and work out the next problem right here. Go ahead and pause the video and you can start it again, and I'll work it out. Alright, starting off with 3.86 liters of carbon monoxide. I don't want carbon monoxide, so I'm going to put it down here. I can go from liters to moles. That's my only choice, liters to moles. And it's got to be the same chemical. So always 1 mole for 22.4 liters. Don't want liters. Those are gone. Don't want moles of CO. I do want oxygen. So I'm going to go moles of oxygen. 1 O2 for every 2 COs. And I want liters of oxygen. Take my units here. Go to liters. And after I multiply and divide all of that out,